So next is a second order high pass Butterworth filter. In the last video we have discussed first order high pass Butterworth filter. The operation of this second order and first order is same but having a difference in a RC network. So this is your RC network where two resistors and two capacitors are connected in this RC network. So that's why it is a second order. Again, this op-amp is used in a non-inverting mode or it works as a non-inverting amplifier. So this is the circuit diagram for high pass Butterworth filter, and this is the frequency response for this high pass second order. Okay, so this is the cutoff frequency FC, right? So this cutoff frequency is basically again depends on the value of R2, R3, C2, C3. So that's why the equation for this cutoff frequency FC is equal to 1 upon 2 pi R2, R3, C2, C3. Right? If the value of R and C are more, then the cutoff frequency will be less from this equation. Okay. The main difference between this second order high pass filter and the first order high pass filter in this RC network first, and second difference is in this frequency response. Right. So what is the need of this second order? Right. To make this frequency response sharper. Right. We have to make this frequency response sharper as compared to first order. That's why this is a second order. Okay. So this is the frequency and this is the voltage gain. Right. This is your stop band and this is a pass band. Again, this is a high pass filter, so this will pass the high frequency within this pass band region and it will block the low frequency which comes in this stop band region, or we can say the frequency which is greater than the cutoff frequency that will pass, and the frequency which is less than the cutoff frequency, that frequency will block by this high pass filter. After that, when this frequency is going to increase, its gain is going to increase, right? If you compare the first order and second order high pass filter in response, okay, in this first order the gain is going to increase by the rate of plus 20 dB per decade. Okay, and in the second order the gain is going to increase by the rate of plus 40 dB per decade, right? The gain is going to increase by at a plus 40 dB per decade, right? And in first order the gain increases at a rate of plus 20 dB per decade. This is the difference between first order and second order frequency response of the high pass filter. Next is the cutoff frequency FC is we have discussed. After that, the difference between this output voltage is V0 by Vin is equal to AVF upon root of 1 plus FC by F raised to 4, and here is a square, right? 4 and square. This also indicates that the gain is going to increase by plus 20 dB, right? And gain is going to increase by plus 40 dB. Okay, and this is the non-inverting amplifier, so the closed loop gain AVF is equal to 1 plus RF by R1. Again, same for first order and second order, right? So this is called as an second order high pass Butterworth filter. Thank you.